Welcome one and all. So in this video I am trying to focus the formulation reaction. Another example is for the orthoformylation reaction is our Reimer Tiemann reaction. So Reimer Tiemann reaction is well known reaction which is nothing but the conversion of phenol into the salicyaldehyde, is well known to everybody, and we'll going to discuss this Reimer Tiemann reaction and features in this video. Reimer Tiemann reaction is a chemical reaction used for the orthoformylation of phenol, and the reaction was discovered by the Carl Ludwig Reimer and Friedrich Tiemann. So unfortunately the photograph of our Carl Ludwig Reimer is not available, and Friedrich Tiemann, this is our Tiemann, his photograph is only available, and this Tiemann is known for both. That's first one is a Reimer Tiemann reaction. Another one is separately what he has created like a Tiemann rearrangement reaction. Now we will go back to the reaction. It's a conversion of phenol into salicylaldehyde. That is our Reimer Tiemann reaction. Phenol, chloroform and sodium hydroxide or potassium hydroxide. We need a base here. So the basic compound is needed here. So phenolic compound, chloroform and sodium hydroxide will lead to the dichlorocarbene as an intermediate. Dichlorocarbene substituted our phenoxide. That is called our intermediate. This intermediates upon hydrolysis will result into the salicylaldehyde. And this particular reaction, our phenol is getting formulated at the ortho position, so that this reaction is called orthoformylation reaction. What is Reimer Tiemann reaction? So the explanation as given already. Reimer Tiemann reaction is a substitution type of the reaction which is named after the Carl Reimer and Friedrich Tiemann. The reaction is used for the orthoformylation of phenol. So here our phenol, our substituted phenol is taking here, and chloroform followed by the base and followed by the O cup will result into the formation of our orthoformylated product. So when phenol is treated with our chloroform in the presence of base, a aldehyde group is introduced at the ortho position of the benzene ring, leading to the formation of the orthohydroxybenzaldehyde or salicylaldehyde as a product, so which is popularly known as Reimer Tiemann reaction. Already we know that in the older days, like in early 19th century, from the coal tar only the phenol can be synthesized or separated. So phenol is known as a carbolic acid and isolated from the coal tar. But nowadays phenol can be commercially produced or synthesized very easily. And in this particular reaction we have a phenol upon treatment with the chloroform in the presence of a base, leading to the formation of our CHO, that is our formyl group. The formyl group is introduced, so that this is called formylation reaction. That too, the formyl group is introduced at the ortho position, so that it is called orthoformylation type of the reaction. And this reaction is given here again, phenol to salicylaldehyde, which is orthoformylation in nature. The mechanism is explained here. Chloroform is deprotonated by strongly basic aqueous hydroxide solution, leading to the formation of chloroform carbon ion. And this chloroform carbon ion is readily undergoes a alpha elimination reactions, leading to the formation of dichlorocarbene as a neutral electrophile and reactive electrophile in nature, reactive species in nature. Again, our aqueous hydroxide is also deprotonates the phenol into the conversion into the phenoxide ion. This negatively charged phenoxide ion is now delocalized into the benzene ring, making it as an nucleophile in nature. This nucleophile is going to attack a dichlorocarbene and result into the formation of the intermediate is called dichloromethyl substituted phenol. Upon this intermediate dichloromethyl substituted phenol on hydrolysis, which offered to the formation of the ortho-hydroxybenzaldehyde, is called salicylaldehyde as a product. Again, the mechanism is explained in a reaction pictorially, and already we know that the chloroform here and phenol. Already we have explained you in the early videos about the during the reaction, one is substrate and one is a reagent, and this particular reagent is treated with the base. So deprotonation is taking place in the both the cases, like in reagent as well as in the substrate. So this is the extraordinary things is taking place in the particular Reimer Tiemann reaction. That's why which leads to the formation of ortho product. First, the chloroform is deprotonated by the help of the base. So already we know the role of the base is nothing but to abstract the proton, so that here the proton is abstracted by the base, leading to the formation of our deprotonated our carbene. So this on alpha elimination, that means our chloroform is deprotonated to form a chloroform carbon ion here. This is called chloroform carbon ion. This chloroform carbon ion on alpha elimination leads to the formation of dichlorocarbene. That is, dichlorocarbene is a neutral species in nature, act as an electrophile. So that this particular Reimer Tiemann reaction is called electrophilic substitution reaction. Now, this is happening in the reagent. This is happening in the substrate. Substrate is our phenol. So phenol, again with the help of the same our base which has added here, this particular base deprotonate the phenol to form a phenoxide ion as an this phenoxide ion for the negatively charged ion is there, which come over here to form a delocalization of this one, and resonance stabilized our phenoxide ion is formed. So that's why in most of the cases we are able to find that why the phenoxide ion is formed during our sodium phenoxide ion compare with our phenol, which one is more reactive and all, so that the phenoxide is more reactive. And so much of that explanations can be available in the case of some of our videos. Here we are focusing with the formation of our nucleophile, our phenoxide ion. This phenoxide ion is seeking our electrophile. So electrophile come over here and substituted here. That's why it is called electrophilic substitution reaction. So nucleophilic attack over a dichlorocarbene. So dichlorocarbene la nucleophilic attack is taking place. That's why it is called substitution is taking place by the electrophile. So electrophile is substituted in this substrate. So this reaction is an electrophilic substitution reaction. Now the electrophile is substituted here to form a intermediate. The name of the intermediate is dichloromethyl substituted phenol, which is again with the help of the hydrolysis, with the help of the base. There is a hydrolysis takes place. So what will happen? K plus and OH minus here. This K plus ion is seeking with one of the Cl here and going as a KCl. Now OH minus come over here to form here. So this is our intermediate is reshaped here. Now this proton is transferred here. In such cases, the pair of electrons is goes to the C and O, thus by forming a carbonyl group and leaving our Cl minus here, so that there will be formation of our aldehyde group come over here at the ortho position, so that it is called orthoformylated product. And this particular reaction is selective in nature. There is a formation with the ortho product only. Reimer Tiemann reaction is an example of electrophilic substitution reaction where the electrophile is a dichloromethylene or dichlorocarbene. So dichloromethylene is electron deficient and is formed by the reaction of chloroform and aldehyde. Dichlorocarbene is a reactive and neutral species that contains a divalent carbon. The carbon holds lone pair of an electron and can exist like a singlet or triplet. That our dichlorocarbene can be existed like a singlet or triplet state, and which is act as an electrophile. If suppose the carbene is existed as a singlet, which leads to the sp2 hybridization called our diamagnetic. So sp2 hybridization, so there is a diamagnetic in nature. If suppose the carbene is in triplet state leading to sp hybridization, so there is a paramagnetic in nature. Now we'll discuss about the applications of our Reimer Tiemann reaction. Now we are taking an example of 2-methoxyphenol here on treatment with chloroform and sodium hydroxide at 60 degrees Celsius, leading to the formation of vanillin. See that here you can ask the question that why there is a orthoformylation may not be taking place, because ortho product is fully blocked. So due to the bulkiness, this particular ortho dash cannot be formed. So there is a free position at the para position, para can be formed. And there is a vanillin already well known to you in vanilla flavor, which has been explained in the previous videos, in the formulation videos. And another example is the phenol. Phenol to 2-phenol to aldehyde, or phenol to carbaldehyde. So which is nothing but the formation or application of our Reimer Tiemann reaction. So in this particular phenol, upon treatment with our chloroform and KOH, leading to the formation of intermediate dichlorocarbene substituted intermediate, on hydrolysis will result into the phenol to aldehyde as a product, which is called as an Reimer Tiemann reaction. Whereas in some cases, the presence of the lone pair of electron cannot be afforded to get our Reimer Tiemann product. Instead of this one, there is a ring expansion product may expect here. See that phenol dichlorocarbene, which leads to the formation of dichloro product, dichlorocarbene substituted phenol, on hydrolysis can leads to the Reimer Tiemann product. Whereas in some cases, this lone pair of electron exists over here, can lead to the ring expansions to get our phenol into the pyridine. So that phenol is an 5-member and there is a 6-member ring expansion is taking place to form a pyridine. So the ring expanded product is called 3-chloropyridine. Some cases this can be possible. So based on the spectral analysis, we can confirm that there is a formation of formal product, or there is a ring expanded product is taking place in the particular reactions. So that these are the things that in the Reimer Tiemann reactions I am trying to explain in this video. Thanks for watching this video. Like it, subscribe it and share it among your friends. Thank you.